Video 2 for 8.3 volumes. This time we're not going to be talking about discs, perpendiculars. Instead, they're going to have a hole or a void in the middle of them. So it's not a complete circle. Instead, it's more of this washer shape. So in this case, we're going to have to find the area of the bigger circle and subtract it from the area, subtract the area of the little circle from that. So for these, we'll be doing a method, okay, perpendicular. So we had perpendicular, and now we're going to be talking about our perpendicular problem, okay, which you can read right there. So here's a nice color picture. Maybe this will be a little bit more helpful. So we have this, and we're going to revolve it around the x-axis to form a solid. Okay, so if we were going to revolve it, we might have this piece, and it would look something like this. And if we revolved it, okay, it's going to have this sort of shape where the inside is kind of going to be hollow. All right, so it would look more like this. This is a great picture. Mine's kind of scary. All right, but the big parts for the perpendicular method is to pick out your radii. Okay, so if you can draw it, you can write it. This top one is cosine. Okay, y equals cosine of x. This one's y equals sine of x. So this big radius is just then cosine of x minus 0. The little radius here is sine of x minus 0. So to find the volume of this, we're going to do volume equals pi times the integral of the big radius squared minus the little radius squared. Oops, squared. There we go. Minus the little radius squared dx. Okay, because we get our width of dx here. And now the only other thing is we need to figure out what x values we want. So where is sine of x equal to cosine of x? Hopefully you remember that's at pi over 4. Okay, so we're going to go from 0 to pi over 4. Okay, now it's just the integrating. Got a nice trig identity coming up here. Cosine squared of x minus sine squared of x. Now, if this was cosine of x squared plus sine of x squared, you would know that would equal 1. But this one's going to be a little bit different. When it's cosine squared of x minus sine squared of x, we can just rewrite that as cosine of 2x. All right, now it's easier to integrate. So I need to correct for that 2 there, so I'm going to divide by 2. And the antiderivative of cosine is just sine. So sine of 2x. And we're going to evaluate that from 0 to 1/4 pi. So I have 1/2 pi times sine of 2 times 1/4 pi, or 1/2 pi, minus sine of 2 times 0. 1/2 pi times 1 minus 0. So we get 1/2 pi for our volume. So the key points to this: draw a picture. Every single time, anytime we're doing volumes, you need to draw a picture. Okay, we haven't dealt with anything other than this right so far, but your cross sections must be perpendicular to the axis of rotation. Okay, before trying to come up with an equation, draw big R and little r. It will help you. Remember, it's top minus bottom or right minus left. Okay, so and don't forget to square each radius before subtracting. So many people, whoops, going back a couple pages. So many people think, oh yeah, it's just pi times the radius squared, and they just subtract and then square it. Do not do that. Okay, so keyword, buzzword of the day, perpendicular. Now we're not going to do all of these, but I do want to at least set them up. All right, so we're going to use the same picture each time. I have the line y equals x. Okay, and I have x squared. Right, so they're going to intersect at 1 and 0. And this time we're going to rotate it about the x-axis. So here's my, this would be my dx. That would be perpendicular to the x-axis. If we rotated it about this, okay, it would be perpendicular. There's going to be that gaping hole there. All right, so we're going to use the perpendicular method. My big radius in the first example is going to be the blue x minus 0. My little radius is going to be x squared minus 0. So now I can just come up with my equation. Volume equals pi times the integral from 0 to 1 of my big radius squared minus my little radius squared dx. Okay, so simplifying this one's easy enough. I'll take the time to do that. Okay, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And we're evaluating that from 0 to 1. Still have that pi there. So I have 1/3 minus 1/5 times pi. And so what would that be? 5/15 minus 3/15. So I get 2/15 pi for the first one. All right, so for each of the next couple, I'm just going to set it up. Okay, so I'll move that. All right, now we're going to rotate it about the line y equals 1 here. So we're going to have this shape, and it's going to be rotated around. Whoa. Okay, back to this. So if I was going to draw my big radius, it would be from this line. So my big radius is going to be 1 minus x squared. My little radius, I was going to draw it, would be 1 minus x. All right, so my volume would be pi times the integral from 0 to 1. Big radius squared, 1 minus x squared squared, minus my little radius squared dx. Okay, and I'm just setting these up. I'm not going to solve them for now. For this one, y equals 2. What would change in this case? No, I can't pull that away. All right. What would change in this case is our axis of rotation. Okay, let's pick a different color. It'd be y equals 2 over here. So my big radius is going to be now 2 minus x squared. The little radius would be here. Okay. 2 minus x. To set up my volume, it would be pi times the integral from 0 to 1 of 2 minus x squared squared minus 2 minus x squared dx. For part D, I would like you to do that in your whisk. Just give me what the big radius is and what the little radius is. Okay, this time you're going with the line y equals -5 somewhere down here. Okay, and for the last one, I'm going to draw it again. The line x equals 1. All right, so here's my two graphs, and I'm going to rotate it now about this line. Oh, x equals -1. Can't do that. All right. Come on. Here's my graph of my functions. X equals -1, so over here. All right, and this was my x squared function. Bad drawing, that's okay. Here's my x function. So we're going to have to do this in terms of y now, because we're going to right minus left. So my big radius would be this. Okay, and solving that, that would be the square root of y equals x. So my big radius in this case is going to be the square root of y minus -1, or the square root of y plus 1. The little radius would be y minus -1, or y plus 1. So for my setup, volume equals pi times the integral from 0 to 1 of square root of y plus 1 squared, okay, minus y plus 1 squared dy. And the bounds still happen to be 0 and 1 because those are the y values this time. Alright, so for the next one, I'd like you to take a look at, if you can do it, that'd be great, but take a look at this equation, this example. We have x squared plus 1, which would be up here, y equals 0, x equals 0, and x equals 1. So we're looking at this piece right here. We're going to rotate it about the y-axis. All right, so we will start with this problem in class. Have a great day.